Hey there YouTube, this is SJM4306 back with another video. This time I've got something very special for you. It's a cardboard box. No, I'm joking. It's this guy. I was contacted by a company called Atomstack. And yes, this is a laser engraver. And I've been wanting one of these for the longest time. I want eventually to get a full-size laser cutter, like one of those CO2 ones. But right now, in terms of the space I have to actually use this and set it up, that's a bit far off. I need to actually dedicate more space and ventilation. So this is sort of a good compromise for me. I will have to worry a little bit about ventilation for this, but this is going to be considerably lower power than that and a little bit safer. And I should still be able to get some nice engravings and cut certain types of materials like wood. But yeah, this is the Atomstack A5. I believe this is the M40 model. But yep, this is the M40 model. Basically, that just means this is a 40-watt device. A little confusingly, it's not 40-watt laser output. It's 40 watts for the entire machine. The laser, I believe, is 5.5 watts for the M40, and the M30 is 5 watts. So decently powerful enough to actually cut through like cardboards, wood, like fairly thin acrylics, I believe I've read it could cut through. And it sort of has this Core XY gantry system. And they very kindly sent a metal cutting sheet. Yeah, it's just appears to be like steel or something like that, just so that you don't damage any table you put this on. Anyway, let's just get into it, and I'm going to grab the camera now and show you guys what's in the package. So pretty much we have all the parts necessary. There's no integrated controller that can just read off an SD card or whatever like most 3D printers have. You actually have to hook this up to a computer and run the vector software on the computer and have it connected the whole time over USB. So yeah, we have a little brush thing, I guess, for brushing away the particulates after they're burnt off. That's interesting. We have the main controller box. This is basically, I believe this system runs off of Gerbil, and I may or may not have done a video a very long time ago about a tiny little like gantry system that I built out of plexiglass and DVD drives. Yeah, so I started building that, and I believe that's effectively what this controller is. It's a Gerbil controller. It's basically like an Arduino with the stepper drivers for each of the axes. Well, we have the power supply. That's definitely very important as well. Let's just see real quickly what value this is. 12 volts, 5 amps. So decent amount of oomph there. As well as, that's actually really useful. It has a inline power switch. So you can just leave it plugged in. We have some, I guess, test pieces. Yeah, looks like some black acrylic, some plywood, like relatively thin. Looks like something like maybe 3 millimeters or something like that. As well as different tools and stuff that we'll need, wrenches and Allen keys. And that's interesting, like a dry erase marker. Okay, we'll unbox that later. We'll get into that later. We have a desiccant bag. Silica gel. Do not eat, throw away. Or is it do not throw away, eat? Anyway, and this being a laser system, I believe it's 4 or 5 nanometers, so it's sort of that Blu-ray kind of color, purplish blue. It has a pair of green protective glasses, which there is a shield on the laser itself, like on the front, but it's still a good idea to wear this, even though there shouldn't really be that much of a risk of blinding yourself. It still never hurts. You only get 2 pairs of eyes. We have very nicely laser. This is probably laser etched. Ironically enough, you need a laser cutter to make a laser etcher. It has a scale on here, which will actually be very useful. Now, one thing that I've read about this is it kind of runs open loop. Well, it does run open loop. There are no positional sensors for homing, so you actually have to manually drag it to a home position, or you can just drag it wherever and reference that as your origin. So that's sort of interesting. Though, from what I've read, you could also fairly easily add the end stops to the hardware. I believe the main controller is just no different than like a global controller, which allows you to fairly easily add your end stops in there. We have sort of the main piece here, which is the X gantry. There we go. And we already have the stepper attached. You'll notice this is a little bit smaller than like a 3D printer stepper, and that's because all it has to do is move a laser around. It's not like a contact-like device, not like a CNC machine or even a 3D printer does have to kind of move around a big hot end. This just has to move around this piece here with a little laser attached. So it doesn't need to be super beefy, and it doesn't need to move super fast either. But yeah, everything is like this super sturdy kind of square stock. So yeah, that weighs quite a bit. And also, all the wheels are these like palm wheels that a lot of like the Ender 3, for instance, uses. Pretty reliable. I've had my Ender 3 running like pretty much every day since I got it. And I think I've had it for about a year now. So definitely put a lot of hours into it. And these guys are super reliable. And it's actually a really neat way of making a motion system. We have some feeties with a little bit of, looks like felt. I think that's felt on the end there so it doesn't scratch your table. And we have a set of 3 of those. And it uses the actual like Gerbil controller box as the 4th foot. And prompt, there's another one below. There's another what below? Ah, okay, there's another one of these. This part of the frame here hiding below there. Now I haven't actually seen the laser yet, so where's the laser? We have some more parts of the frame. This one has a like logo on there very nicely. Silk screened on there, and hopefully I'm not missing the laser. I wonder. Give me a sec. I'm gonna go through. Maybe I misplaced the laser or something. Give me 1 sec. Hopefully it's not missing. Ah, okay. Whew. I thought the laser was missing. I got to everything else except for what I was really interested in. This is the Plum Blossom screws. Okay. Yeah, this is a laser module. And it has a little bit of heft to it, but yeah, there you go. That end is the death ray end. And it has its own controller on top. And that basically does all the power stuff. And it just gets a control signal from the main box to tell it to turn on and off. And I'm not sure if this does a like grayscale. It possibly does, but a lot of the images I see from machines in this range seem to do dithering, so it might just be on off. But I know you can actually adjust like the global power level. And oh yeah, basically like a massive heat sink, because yeah, if this is a 5.5 watt laser, even at modern like diode efficiencies, there's still going to be quite a lot of heat that it pumps out. So there's actually a fan built in as well, just to cool the entire casing, and the diode's clearly going to be mounted like it onto the casing like a heat sink there. Yeah. Anyway, that should be it. Yeah, that should definitely be it. I will say everything's very well packaged, and everything has its... They've clearly thought about the packaging of every single thing goes in, has its own little perfect spot there. I'm sorry, I just have to stop right here and make a note. They really did go all out on labeling everything like by step, and their instructions are actually really good. I'm liking this. This is going to be a joy to assemble, so let's get to it. Yeah, step 1. Just screw together the frame. I'm actually going to get something square, and just to make sure that everything is perfectly square, because if these are going to be slightly cocked at an angle, that's going to affect the binding of the wheels, as well as like the geometry will have an offset. But anyway, step 1 done. Step 2, let there be feet. Okay, one thing I had to do was actually tighten both sides of these up. So you'll need the second size Allen key to hold this bolt. You'll need to loosen, using the smaller size of this wrench, you'll need to loosen this bolt a little bit, and then you use the larger side of the crescent wrench to get underneath. You can see that silver part right in there. That's it's an eccentric nut, and you just need to either tighten it or loosen it depending on whether this is too tight or too loose. And then once you get it in perfect position, then you use the Allen key to snug it up a little bit while holding on to the eccentric nut. And then once it's just snugged up, then you go on the other side of here, hold this nut, and then tighten it the rest of the way with the Allen key. And you want to get it so that there's no play. So when I first put on, I noticed it was kind of super loose. Now, there's no play. It's maybe a little bit tight, so I might back it off on both sides a little bit. But yeah, you don't want it too tight or too loose. If it's too tight, you'll notice it'll start digging into these wheels, and you can see it like powder forming on them because it's actually eating away at the wheel. The metal is rubbing too hard against it. If it's too loose, you'll have kind of the opposite problem. It'll be kind of too much play and inconsistent laser cut results. Step 3, let there be belts. Now, I pretty much put the front side, only have a tiny little overhang, and I put most of the remaining belt on the back side so that I can continue to adjust it. So I'm actually going to continue on with the build. I'm not going to put these end caps on just yet. Going to see if these are too tight or what. I just put them a little bit taut, but have a little bit of give as well, so that this guy can move fairly freely. We'll see how it goes, but once I get it down, then I can cut these off a little bit and put on the end caps. Oh, laser, where art thou? Oh, there you are. Took me a second to figure out how this works, but basically there's like a C-shaped sleeve here, and then there's a cutout on the laser, so it's captive more or less. It can slide up and down, and then what they call the blossom screw is actually just kind of a set screw that you can use to set the height, then tighten it down, and then it'll remain at that fixed height. You can see the red window in the front there so that you can see like the nozzle area without having the risk of incidental light, bouncing out, blinding you. And last but certainly not least is this little nub here. It's an M3 and then a little standoff. And you'll notice in the back, one's already pre-installed back here to prevent the laser from sliding off that way. And you just got to install the one up front here. And this acts as a mechanical end stop that will physically prevent the laser from trying to run at you. Again, it looks like step 6 is just to do the wiring. This is pretty straightforward. Just the bundle of wires that are coming off of the controller box. And I just have to plug them into all the different motors. And they tell you exactly which one goes where, so that's fine. And they give you a load of zip ties here for tidying up the cable. There really isn't any built-in cable management. You just sort of let the wires flop around, but try to zip tie them down in certain areas where they show you for like strain relief reasons, that kind of stuff. And I'm going to skip that for now. I'll do that on my own time. And more importantly, I have to actually download the software. Now, you have to install the CH340, which is a serial USB bridge chip. A lot of Arduino clones will use that. I use that a lot, so I already have this driver installed. But luckily, if you download the Laser Gerbil software that they link, within the software itself, you just go to Tools and click Install Driver, and it'll do it for you, which is fantastic. But I am going to have to download the whole Laser Gerbil software anyway, and I have to also install macros, which are buttons, I think, specific to this model of laser cutter here. Also forgot to mention, very nice warning label. I love warning labels with like laser blinding and cutting people and stuff like that. All these little symbols. I love it. Just makes it feel more dangerous. I love danger. Okay, I just had to know what was inside the little control box, so I opened it up. It was the 2 screws holding it onto the rail there, 2 and then 4 outer screws, and then 4 inner screws holding it to the box itself, one of which stripped. Yeah, one of which stripped, and I had to take a Dremel and cut a slot in it so I could use a big flathead driver to torque it out. Anyway, I said torque, not twerk. Anyway, it is out now, and exactly like I thought. It's an ATmega 328p, and the board is marked LazorBox V 1.0 on the front, and on the back it has their nice logo, Atomstack, on the silk screen. Here you can see a lot of features are actually unused on this board. There's an auxiliary port, as well as like a number of headers. There's the ICSP port to flash the ATmega, a reset button. We can see like a poly fuse. This is a power supply section. It's fused. There appears to be either that's probably the main regulator, and there's another like DPAC surface mount component, and I believe the location close to a screw terminal called motor. I guess that's probably a MOSFET for driving like another external motor or something. And there's another 2-pin socket called laser, which ironically enough doesn't have anything plugged in from it. I didn't unplug any of these wires or mess around with them. So the laser isn't being driven, ironically enough, from laser, but there is a 2-terminal socket here, and it's just labeled GS. I don't know what that specifically refers to. If it's a MOSFET, maybe gate and source. And only one wire is actually connected to anything, oddly enough. And then the other 2 wires go over to, it says 12 volts V out. So yeah, I'm guessing this is the 3 wires that go over to the laser module. So it's ground, power, and then this is sort of the enable or PWM pin. And there's another one that says 5VO. So I'm guessing that's a 5-volt output if you wanted to power something else. So in addition to that, we have the CH340 here. That handles the USB communications to serial to UART. That actually is what communicates with the chip over USB. And then we have a row of headers here. One of them called probe, extra, ZV, YV, or, oh, no, sorry, it's VGS, but it's Z, Y, and X, and I believe these are the end stops. So if you did want to install end stops, you'd have to physically wire them to these for X, Y, and Z. In this case, you don't have a Z, you just have X and Y. But you would need to probably modify the firmware. The firmware that's burnt to here currently has, it's not looking for end stops. It's probably not, it's disabled in the software. So I noticed in the laser software that they suggested to use, Laser Gerbil, the PC side application, there's actually a button to upload firmware, and one of the things says like with end stops, and the other one has them without. So I'm guessing you'd have to burn that, but just to be safe, I'm probably going to try to dump the firmware just in case they wrote some different fuses, or they're using eastward prom or something, and make a complete backup of this chip before I mess with anything, just so that I can go back to a known state in case I screw something up. But I probably will eventually want to add end stop so that it could home itself. Anyway, in addition to that, we have extra, so these are all the stepper drivers. There's 3 of them, and there's 2 wired, obviously, for the X and then Y1, and then there's a Y2, interestingly enough, and then the Z. The Z isn't even used at all. I'm guessing Y1 and Y2 are wired in parallel, and that's sort of if you wanted to use 2 motors. So right now, this actually just has 1 motor driving the Y-axis, and it's coupled over using this beam. If you want to have two motors for higher torque, like for instance for CNC, you would probably want to use two motors to drive the gantry. Otherwise, you might stall out or have some mechanical issues. So I'm guessing that that's what that's for. And then Z, clearly, if you had like a CNC or 3D printer build that required Z-axis control, this doesn't require that, so it's not used. And they didn't even populate the stepper motor driver in that portion. And each of these jumpers are used to set microstepping, I believe. And another important, interesting thing, obviously these have heat sinks, but there's a potentiometer to set the constant current limit on each of these modules. So it would actually be easy enough to reuse this board, and if you want to turn this into like a 3D printer. But yeah, I just thought it was interesting. Just want to take a quick look at what exactly was going on here. Okay, so for my first test, I just loaded a bitmap image that I drew of a little pointer finger, and this was actually the icon that I used in my Digital Magic 8-Ball project. And I just drew it in Paint, and I imported it here. I set the laser power level at about, I think, 25%. And I just ran a quick test just to see, and it actually is like very close to marking right through this paper. I'm going to actually lower the power level just a tiny little bit and rerun this test. I just want to see what the average power level I should set just to score, like to mark the paper without cutting through all the way. You can see it actually did cut through, so I'm fairly close to the limit, I'm guessing. There we go. Okay, so let's get set up. So this is low enough power, it shouldn't do anything. Let's just see where it's going to draw. So it's going to do it in this corner right here. Let's see one more time. Yeah, that's good. So let's let it burn. And there we go. So let's see how this one came out. Okay, so it's a little bit under, so probably somewhere in between. I think I set this to 30% laser power, and this was, let me just double check. I think it was 25%. It was 20%. So I think maybe 25% would give me the best chance. Somewhere in between the two there. And there we go, I can already see this is pretty much perfect. So on paper at least, let me start writing this down. So basically what's going on is, at least for the power, this guy was at 300, which equals 30%. It does this in terms of like 1,000 equals 100%. This was 200, and this was 250. I think 250 gave a very good, clean outline. 350 would probably give a nice, like, straight through burn. Okay, we're all good. And this was 350. And you can see, I mean, there are a few stragglers, but if I take like a pin, I bet you they're barely holding on. You can see most of them have just popped out, these little tiny little squares of paper. And on the ceramic block that I've been cutting, you can see there's a whole bunch of those little pieces that came off there. Let's do something a little different. Okay, so here I am going to do something much larger, well, relatively larger. And I'm just going to frame it, make sure that it doesn't intersect with anything else. Like that should be good. Okay, and I'm at about 220 now, so that's like 22%. I'm just going to do kind of a line engraving. Hopefully it doesn't cut all the way through. Okay, so it looks like it finished up. And you can see it smells a little bit like some kind of burning potato chips or something, or paper, obviously. But yeah, you can see here, seems to be a little bit maybe too powerful for engraving paper, because it basically obliterated the paper. You can actually partially see through. It's sort of like a mesh screen more than an engraving. So I would probably need to turn the power back down to 200 or maybe even a little less than that, just looking at this. But yeah, in terms of the time to do that, that was about 5 minutes. And my computer went to sleep halfway through, and it paused, and I had to wake up my computer and log back in. So if you are going to be using this with a computer, make sure you disable any kind of auto timeout or sleep mode, because that'll screw up your job, unfortunately, there. Yeah, you can see perfect. Look at that, almost lined up exactly. Well, sort of. There we go, something like that. But yeah. And just for fun, I decided to cut out. This is at, I believe I set it to 400 or 450. There we go. Let's just get this out of the way. And it's most of the way through. Some of it didn't quite cut, so I would actually increase the power level. But yeah, you can see it's the pedestrian light, basically the symbols that I used. I just loaded up the DXF file, and that was pretty easy. Yeah, I set this actually to 350, so the same as this guy, and it's just barely hanging on. So I would probably increase it to about 400, and that should cut completely through. Actually, that was just held on basically by just the burnt remaining material. I just gave it a light tug, and it just pulled right out. So yeah, I think 350 through just standard office printer paper worked perfectly, and you can see just how sharp the details are. The spacing right between the fingers there, that's crazy. That worked a treat. Let's try some other materials. Now, I did these indoors just because it was paper and it was relatively low power, and I started at the low end while testing, but if you're going to do anything like any plastics or wood, you need proper ventilation. So I'm actually going to take this outside, and we're going to run a couple of engraving tests on like different kinds of wood, cardboard, that kind of stuff. Something a little bit thicker, but that has the potential possibly to create more smoke and or catch fire. So fire safety first, doing this outside or in a very well ventilated area. So yeah, I went to the dollar store of all places because I know they have a lot of craft stuff now. Bought some construction paper in a lot of different colors, and I bought, interestingly enough, for $1, plywood planks, or I think they're 3mm, and you get 6 of them for $1, and it comes in a little Ziploc bag. That's a really nice thing. That's a good deal if you just want to do small crafts like this. So I'm going to use this as a test substrate so that I can see how many passes I really need to actually cut straight through something like plywood. And for the construction paper, so here you can see I've done a bunch of random things. I did a little Hello Kitty thing. Christmas is coming up and my sister likes Hello Kitty. Also did a map, And I actually meant to only engrave this, but apparently, yeah, you can't really just like scorch paper. It either just burns completely through or not. So that didn't exactly work out. All these are separate. If I just poke my finger, all the little bits will pop out quite easily. But anyway, thing that I came up with that will hopefully help is I noticed if you didn't have the whatever you're cutting like perfectly flat, and there's some, vertical difference in the material, some parts will cut completely through, some will just like slightly scorch, some won't even do anything at all. And so what I ended up doing was I took this, I believe this is steel, a steel plate from something, some little neodymium magnets, and I stuck it down. So now I can use this as the substrate to cut on. Also have a sort of like a ceramic or a fire brick, whatever, just to kind of raise the height. Because I've noticed, at least on this table with the feet and everything set up, to really get the laser in tune, it would actually have to drop below this plate here, and you couldn't screw it down. So this is about as low as it'll go, and it's the perfect height for both this piece of metal as well as what's under it. Another thing, let's see where I put that. Yeah, here we go. This is super delicate. So I printed out, let me just pick this up, this like tree kind of mosaic pattern. And that's absolutely crazy how much detail that printed. This is only about the size of a quarter. So about, a little less than an inch diameter. You could see just how fine of a detail you can print. That's crazy. This is paper, obviously. I want to try doing this on wood, both engraving and seeing if I can maybe cut through if it's thin enough. But anyway, yeah. I've been doing the paper cutting inside, and it makes a little bit of smoke. I wouldn't say much more than burning a candle. But if I want to cut the construction paper and this wood, that'll definitely create more smoke. So I'm going to actually run this outside and run some tests. Oh yeah, I forgot to mention, I bought a bunch of this vinyl, thinking, oh, that would be cool to kind of cut your own stickers. And then I realized after I bought this that these are made of PVC. And if you cut PVC with a laser, well, if you heat it up sufficiently, it'll release chlorine gas, which if you happen to breathe that in, it'll form hydrochloric acid in your lungs and probably kill you. So we're not going to cut this. I'll just save that for another day. Maybe I'll modify this one day to add a blade so that this can, cut using like a stylus or something like that. But anyway, yeah, you have to be really careful with what you try to cut on this printer, because there are certain things that are toxic and definitely bad. And also, one other thing to mention, if you do decide to cut things that are potentially toxic, even if you do it in a well-ventilated area and whatnot, the gases they release could actually react because, they're underneath this kind of, I guess you could consider this like a tiny little fume hood. The gases can actually flow up and react with the metals inside and the laser diode and everything and the lens, and it could actually destroy your lasers. So yeah, best to cut things that are on like the approved list of laser cutting materials and not to stray too far unless if you want to risk possible damage to your machine. Okay, so we're set up, and within the interface, I'm going to hit, sorry if the brightness is a little bit, I'm outside right now. So anyway, we can turn on the laser for focusing, which is this button. And I can just about see a dot. It's actually in pretty good focus right now. Turn this off, turn on, if I click this, it'll light up the path using low power and then show me where it's gonna actually cut. So there, we can see it's aligned with the paper pretty well. And I am currently set, let's see, I think I'm at 35%, so let's just run this and see if it cuts all the way through. And there we go. Yeah, looks like it is, looks like it is barely hanging on, so 35% on cardboard looks just as well as on paper. I can get my fingernail up on there. Let's see. Yeah, there we go. So you can see it left a little bit of fibrage, I guess you could call that. But yeah, that'll cut just fine. Next up, let's grab the plywood and see what we can do with that. Sorry about the AC noise. Anyway, figures it's gonna kick on right when I'm gonna make a video. So I've raised the laser a little bit because this material is thicker. And this 3mm plywood, like I said, I am running the same test. However, I increased the laser power to 100%. And we're just gonna do one pass right now and see how deep it gets. Oh yeah, you can see that smoke. So yeah, very clean cut. However, you can tell it did not, there you go, you can tell it did not penetrate completely through. So give me 1 sec. I'm gonna run a couple of different tests, increasing the number of passes each time. So this is one pass. Okay, things I've learned. It's very cold outside. So paper cutting from random testing that I've done is 350 will cut completely through. 200 and a little bit below will kind of mostly scorch it, but not quite all the way. You can see this construction paper cut pretty easily at 350. I might increase this a tiny little bit because it left a little bit, some fibers between. It wasn't quite a 100% perfect clean cut. And by the way, these numbers are the laser power represented out of 1,000, so 350 is 35%. And I left the speed actually the same. I believe I left it at 1,000 millimeters per second or something like that. Yeah, so for the wood, I ran a series of tests. All these are at 100% power, so 1,000 on the laser power. And the speeds were all the same. All that I changed was the number of passes. And you can see if you want to engrave, you want to do that at one pass. That'll leave kind of the sharpest line without burning the surface. And you can see it won't even touch through the other side of the wood. 2, it's a little bit darker, but then you start getting the surface burning. And pretty much 3, 4, 5, you get more and more of that extra burning from the extra passes. You can see in certain areas, namely the corners, we're starting to get points on the bottom side where it is going through. And I'm guessing that's because it lingers a little longer at the corners when the laser's moving, because it's a mechanical assembly. It has some mass and inertia and whatnot. And you can see here at this point we start getting to the very close to almost popping through, and that's at 6 passes. At 7 passes, we actually get significantly through, and I'm sure if I pushed this with some force it would pop out, but it'd leave a pretty jagged edge because you can see there's still some points, interestingly enough, on the vertical portions where it didn't cut through all the way. On the horizontal it did, and I believe that's due to the shape of the beam isn't exactly circular, it's not exactly square. I believe it's more of a rectangle, and so it's probably aligned horizontally, which is why when it goes through horizontal, that actually average power is actually higher than when it goes vertically. And at 8 passes, you can see the piece popped right out. And the edges of the cut are actually pretty clean, and they're pretty straight as well. There is a slight curve, possibly, at a downwards angle. But yeah, it's pretty hard to tell. It looks pretty clean to me. Edges are very burnt. It smells very smoky too. But I actually kind of like the smell of smoky wood. But anyway, yeah, that cut fantastically, and it went all the way through, and it actually marked the piece of metal. It didn't really mark it per se. It's actually the soot from the wood, and I actually wiped it off and it got stuck on my finger. So yeah, so this isn't going to really be able to, definitely not cut metal. Engraved metal, not directly. If it's anodized, then yes, it can actually remove the oxide layer. Or if it's a painted metal, then it could remove the paint, but it's not doing much to the metal itself. I've seen people kind of engrave clear acrylic plastics and glass using either paint on the other side so that the paint heats up and it starts, transferring thermal energy into the acrylic, and that's why it makes it visible. Or I've seen someone put it on like a metal sheet, and I believe what's happening is the metal is reflecting heat. It's basically absorbing the energy of the laser beam and heating up, and that's what's transferring the image, so to speak. I don't have any acrylic right now to test with, unfortunately. I probably will do a follow-up video where I'll get some different colored acrylics and just to test them out. But as for now, this is all I had. But anyway, yeah, this is absolutely viable. I can definitely see myself getting larger sheets of plywood and making like my own custom wooden enclosures for different things. It will take quite a while, 8 passes for this. It took 5 seconds for 1 pass, so eight would be, roughly 8 times that. If you're going to do a large piece, obviously you'll have to factor that in. Now, it was actually pretty windy outside, so I think that definitely helped. It was a significant amount of smoke coming off of these as I was testing, and it was definitely blowing that away. But I think what would definitely help these sort of burn shadow marks as it goes around multiple passes, you can kind of see some like bleeding. I believe if you had an air assist hooked up to this, that would definitely help with that. And that probably will be my next future modification of this. I do have like an aquarium air pump, a small one. I'm wondering if that would be sufficient. If not, I have plenty of like blower fans from projectors and computers. That would definitely have the CFM necessary, and then some. It's just a matter of opening this laser module and finding a way of routing a tube down and like angled towards the nozzle there. But that'll be a future video. That'll take me some time to get hammered down. All in all, this was my first experience with a laser engraver / cutter, whatever you want to call it. And this worked great. Assembly was actually really fun. I really enjoyed the assembly. It was very clearly diagrammed and explained in the manual. Went together a breeze. If you've ever built like a robotics kit, or if you had one of those earlier kit 3D printers that you had to build yourself, this is an absolute treat. It's built very similarly to like a 3D printer. So if you're familiar with the Cartesian kinematics of like the belt drive system, this is absolutely child's play. Even if you're not familiar with like building this kind of stuff, it actually went together pretty easily. It might take you maybe twice as long. All in all, it took me maybe about an hour-ish, and I wasn't particularly rushing or anything. As for the use, I'm using Laser Gerbil, the free software they suggested. There's also, I forget what it's called, like Lightburn or something. And that, there's a free 1-month trial, and then you have to pay for it after that point. I might give that a try. I believe the paid version of that is like 50 or 60. No, actually, I think it was like 40 or 50 bucks, somewhere around that point. So I don't know if my use would warrant me paying that much money for the software. I think I'm pretty happy with Laser Gerbil. It does what I need. Most of the other software that I use for like drawing all this stuff and like laying it out, scaling it, doing all that is Inkscape, and that's freeware. And I'm not particularly great at that. I'm still learning. It's actually pretty good from what I've seen. There are some oddities. I'm used to using engineering CAD programs, so there's some things that it does that don't really seem obvious to me, or it seems very odd the way that you have to do certain things. But yeah, it's just practice. I'll get used to it, and I can design more and more complex things. I can do artsy kind of stuff. So we'll get around to that. But anyway, yeah, if anyone is interested, I will have links down below in the description. I believe, I want to say this retails for, this is the M40, by the way. They have a couple different models with slightly different like power ratings, and this is towards the higher end. I don't believe this is the highest end one that they have, but I believe the price last I checked was like, I believe it was like 400 something. Which isn't particularly cheap, but it's actually kind of in line with some of the better 3D printers. So it's definitely, if you're into making this sort of stuff and you want to get more serious and maybe even make your own side business, cutting out different shapes and stuff like that, signs and that kind of stuff, this is definitely a good investment, I think. It pretty much takes all the trouble of physically sourcing the materials and building it yourself. And all the software is open source enough that you can get free software to do whatever you need to do to draw shapes. But no, yeah. Once again, huge thanks to Atomstack for sending this guy in. It's actually been really fun playing with. I've been meaning to play with like a laser cutter for quite a while. Now, I've mentioned this several times, but keep in mind, yeah, this isn't going to cut anything clear. It's not going to cut like super thick materials, not going to, pretty much not going to do much to like heavier duty materials like stone or marble or metal, anything like that. It probably won't do much to glass. It won't really do anything to, not directly anyways. So this is more tailored towards pretty much what I've shown, like relatively thin plywood, different types of papers, that kind of stuff. But anyway, yeah, if you guys are interested, links will be down below. And if you guys have any general purpose questions, this almost definitely will not be the last video I do on this guy. I need to do plenty more experimentation. All this was just an initial run to learn how to use the machine. Now that I generally know how to use the machine, I'm going to look to push it towards its limits, find out what they are, and experiment with like different types of materials and that kind of stuff. And I was just doing cutting, but I definitely want to test this out, doing some kind of like dithered or grayscale engraving, so I can do images and stuff like that. I think that would be really cool. But anyway, yeah, hopefully you guys enjoyed this video, and I'll see you in the next one. Bye.